Welcome to Training and Instructional Design. This will be a lecture on selecting and working with media. This is Lecture B. The learning objective for the Selecting and Working with Media unit is to design simple online tutorials using screen capture software.
In the next couple slides, we will discuss some important concepts about images. This knowledge will help you work with images so you can embed the correct image file types and sizes into various training materials, such as print training manuals, PowerPoint presentation, and online training courses. In addition to the basic concepts presented in this unit, you should do some hands-on exercises with various image editing programs that are distributed with cameras and computer operating systems. What kinds of images can you use in your training materials? The first type of image that may come to mind is a photograph. You can use images of clinical setting or equipment to enhance the learning. A special type of photograph is a computer screen capture, a digital image of a portion of a computer screen or the entire screen. Some computers come with screen capture software, or you can download free trial versions of software applications such as Snagit. Another type of image is a graphic or drawing. These images are not photographic quality, but can be very effective in illustrating various concepts. Graphic images have their own file format, a GIF file. We will discuss image file formats in a few more slides. Now let's examine some basic characteristics of images: image size, resolution, file format, and compression, and finally how these characteristics affect the output of an image. The output, or the way you will display an image, must be considered at the start of any project where you are collecting and editing images. One of the first things that must be decided on is how large an image will be displayed on a printed manual or on the computer screen. This is very important if you are scanning images from another source, but less important for photograph taking with more digital cameras. If the image you are scanning is 2 by 3 inches, and you display the image at 8 by 10 inches on a printed page or full screen on a computer monitor, the image may be pixelated because you did not have a high resolution during the scan. Image size and image resolution are closely related, so now let us look more closely at image resolution. Confusion can arise because image size is specified by the number of pixels, the resolution in dots or pixels per inch, DPI or PPI, and the physical size, width and height. But the only attribute that counts is the number of pixels in the original image. First, 4 basic concepts about resolution and size. If you decrease resolution, the width and height will increase. If you increase resolution, the width and height will decrease. If you increase the width or height, the resolution will decrease. If you decrease the width or height, the resolution will increase. A pixel is a tiny block of color and is a digital image's most basic building block. A digital image is composed of thousands or millions of individual pixels. The more pixels an image contains, the greater its detail. 1 million pixels equals 1 megapixel. Therefore, a 3.1 megapixel digital camera can take photographs that contain more than 3 million pixels. Most image editing applications display an image's resolution using pixel dimensions, with the horizontal measurement coming first. For instance, an image with dimensions listed at 2,592 by 1,944 would contain 2,592 horizontal pixels and 1,944 vertical pixels. Multiplying these two numbers gives you 5,038,848 pixels, or approximately 5 megapixels of resolution. Several file formats are used for image storage. The most popular formats are JPEG, GIF, PNG, and TIFF. The primary difference between file types is the type and amount of image compression. Compression reduces the amount of space required to store an image on a disk. JPEG 2000 is an update of JPEG that offers a higher degree of compression at the same image quality level. It also has options for fast display when full resolution isn't needed, which makes it well suited for web browsers. BMP, Windows Bitmap Format, is a common uncompressed file format. but TIFF is a more commonly used uncompressed file format and should be used whenever possible to archive original images before resizing, cropping, etc. There are two types of image file compressions, lossless and lossy. Lossless compression maintains all the original image detail. Typical compression ratios are 30 to 50%, depending on the detail in the image. The more detail and colors in the image, the less the compression. PNG files use lossless compression. Lossy compression sacrifices image detail in order to achieve higher compression ratios. The amount of compression depends on the detail in the image and the quality level selected when the image is saved. JPEG and GIF use different types of lossy compression. In addition to the standard file formats, many digital cameras have the option of storing images in RAW format, unaltered data straight out of the image sensor. Pixels per inch, PPI, and dots per inch, DPI, are technically not the same thing, but they are often used interchangeably. PPI refers to the number of pixels found in 1 inch of a digital image or a computer monitor. While PPI does not affect the actual quality of the image itself, it can affect how an image appears on a web browser or in print. DPI, on the other hand, refers to the amount of resolution a printer is capable of outputting. Printers use dots of ink to render an image. The more dots a printer can produce per square inch, the better quality its output. Though many image editing programs, including older versions of Photoshop, contain settings for changing an image's DPI, most of these applications are really only altering the PPI settings. The apparent PPI, or density, of a monitor depends upon the screen resolution, number of pixels, and the size of the screen in use. If two monitors have the same resolution, but one is 4 times as large, the larger monitor will have a lower PPI, or pixel density, and when viewed close up, you will see the individual pixels. Computer monitor displays images at 72 pixels per inch. This means a 3.8 megapixel image is going to measure about 32 inches by 24 inches when viewed on a monitor. Good quality photographs usually require 300 dots per inch when printed, although professional photographs are usually printed at a much higher number of dots per inch. When you increase the pixels per inch, you reduce the size of the printed photo. If you print a 3.9 megapixel photo at 100 ppi, the photo will measure 22.7 by 17 inches, 2272 by 100 equals 22.7, and 1704 by 100 equals 17. If you print the same photo at 250 ppi, the print size is 9.1 by 6.8 inches. 2272 divided by 250 equals 9.1, and 1704 divided by 250 equals 6.8. Here are some guidelines for image resolution and image print size. Image resolution maximum print size: 1024 by 768, 4 by 6 inches. 1152 by 864, 5 by 7 inches. 1600 by 1200, 8 by 10 inches. Videos can be a very effective training tool, particularly for training users in computer applications such as EHRs. There are several very effective and easy-to-use screen capture programs, and after you understand the basic concepts in the next couple slides, you should download a free trial version of a screen capture program such as Camtasia and view the online tutorials. You can view several examples of EHR training videos at this Michigan State University website, www.emr.msu.edu/trainingresources/menu.htm. We just spoke about one source or type of video used in EHR training, screen captures. But you are probably most familiar with digital video cameras found on cell phones and even on most still digital cameras. Video cameras can be used to record techniques or skills, and they are also useful in training course evaluations. You can record your presentation to critique your classroom delivery and public speaking presentation style, and the video recording of computer-user interactions can be a useful tool to evaluate computer systems. The online lessons you are using in this course are another example of videos in training. These training videos are created by recording a speaker along with a PowerPoint presentation and then converting the voiceover PowerPoint to a video file. You can also use the PowerPoint file in its original PowerPoint show format. There are several programs that convert PowerPoint to video, such as Articulate and Adobe Presenter, as well as Camtasia, which we can use for screen captures. In addition to technical issues associated with video, there are adult learning theory principles that should inform your video production and use in training. Chunking video is the concept of dividing a long video sequence into discrete elements that focus on one concept of task. Each chunk could be associated with one learning objective or user task you defined in your ADDIE analysis phase. This is based on the theory of data chunking. For the brain to store data for easy retrieval, it chunks information into small, discrete pieces. Visually, it helps to chunk data by making lists, graphs, charts, slides, bullet points, etc. And in video, you can create chapter or an index to jump to a specific section of the video. Many people still think of video as a linear videotape, but you should see video as a collection of individual chunks that can be accessed randomly or in sequence. Video file format are also referred as containers or wrapper formats. Examples of video formats include Apple's .mov, MPEG-2 used in DVD videos, DivX, and MPEG-4. Issues to consider in choosing a video container format include how widely supported a container is supported, overhead or file size, support for advanced content such as chapters, subtitles, meta tags, user data, and support of streaming media. In addition to a video format such as MPEG-4/H.264, file formats use a codec or compression format. You must make sure that the computer that will play back the video has the correct video player format and the codec that was used to compress the video. For example, QuickTime is a video codec used with the MPEG-4 or H.264 video format. Before you commit to using videos in your training, you should first look at the information you gathered in your analysis phase for organizational and workplace environmental factors that may impact the delivery of the video to a computer in the clinic. Other factors to consider are: will the audio disturb other workers, or could the learner use a headset? Does the network security allow streaming video to be delivered to the computer in the clinic, and are there any restrictions on playing back the video on the computer workstation? Does the computer have the proper video play and codecs to play the video, and does it have a sound card? In the analysis phase, you should consider factors that will impact the delivery of images and video you may want to use in your training. Can you name several factors that will impact video training materials? What adult learning principles could be applied to videos and images? In the unit, we discuss the most commonly used image and video file types, and how they can be incorporated into training material. Most media must be edited and formatted before you can place it into your training material. This unit discussed the relationship between image resolution and size, how these characteristics are related, and the technical consideration you should consider when distributing video to your students.